This is Appendix A, page 3, and we're continuing to solve quadratic equations. Remember, a quadratic equation has an x squared in it, and so for example 6, we're going to use the quadratic formula. Now the quadratic formula, just to remind you, looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So we're going to use this formula to solve this equation because we cannot solve it by factoring nor using the square root property. The first step to solving is to subtract the 3 because we want to get this in standard form. And then a, if you remember from the quadratic equation, a is the coefficient of x squared. So a is equal to 1. B is the coefficient of x, so this is 6. And then c is the constant, which is negative 3. And then we just plug these numbers into the formula. And then we simplify that. So we have x is equal to negative 6 plus or minus. Underneath the radical we have 6 squared, which is 36, and then that becomes a plus 12. So 36 plus 12 is 48. Then we want to take out all perfect square factors. Well, 48 is 16 times 3. So we can take out a perfect square of 4. Now we're not quite done because do you see how the 2, the 4, and the 6 all have a common factor of 2? So I'm going to factor out a 2 from each of the terms so that we can divide the 2 out. So now we have the two solutions, negative 3 plus 2 root 3 and negative 3 minus 2 root 3. Another way that we can solve quadratic equations is by completing the square, and that's where the quadratic formula comes from. I'm going to go ahead and do this another time using the completing the square method, just to remind you of how it works. If you're planning on going higher in math, then you'll want to understand this method because it's used in other cases too. So we're going to be completing the square. And to do that, we take the coefficient of x, which is 6. You take half of 6 and then square it. So I'm going to go off to the side to do that. So half of 6, which is the same thing as 6 over 2, and then square that. Well, 6 over 2 is 3, and 3 squared is 9. So I'm going to add 9 to both sides to complete the square. So I'm completing the square on the left side, but I also have to add it to the right side. Since we are solving an equation, whatever you do to one side, you have to do to the other. Then we can factor the left side. Factors of 9 that add up to 6 are 3 and 3. So you can see both of the factors are the same, and we've got a perfect square. Then for the rest of it, it's review. Remember how to solve by completing the square? By the square root property. So we take the square root. It's plus or minus the square root of 12, and then solve for x. And you can see that we get the same two solutions. Since 12 has a perfect square factor of 4, it comes out as 2, and then the factor of 3 stays there. So we get the same solutions here as we did when we were using the quadratic formula. Using the square, completing the square method is nice when the coefficient of x is even, because then when you take half of it, it's just a nice number. If the coefficient of x is not even, and or if you have a number in front of the x squared term, so coefficient of x squared, that's not 1, then completing the square can get really messy. The last part of this section, we're going to solve linear inequalities. A linear inequality can be written in the form ax plus b is greater than 0. It could also be written, instead of is greater than sign, you could have is less than sign, or is greater than or equal to, or is less than or equal to. Those are all inequality signs. The first example, we want to solve for x. We use the same method as when we're solving equations. So I first want to subtract the 7 from both sides. And then here we have to be careful. Whenever we multiply or divide by a negative, do you remember how we have to switch the sign the other way? So x is greater than 6. So when we're solving inequalities, you can see that we have an infinite number of solutions. We can show the answers with a number line also. It's anything that's greater than 6, so we use a parenthesis to show that 6 is not included, and shade to the right. Or we could use the interval notation from 6 to infinity. So any number that's greater than 6 will satisfy that inequality. Example 8, solving a 3-part inequality. For this inequality, whatever we do to one part, we want to do to all 3 parts. So if I'm trying to get x by itself, I'm first going to add 8, but I need to do that to all 3 parts. We have 9 is less than or equal to 6x is less than or equal to 12. And then getting x by itself, we have to divide all 3 parts by 6. Simplifying the fractions, we have 3/2 is less than or equal to x, which is less than or equal to 2. So any number that's between 3/2 and 2, including the endpoints, will satisfy this inequality. To show that the endpoints are included, because there are equal signs, we use brackets. And the same thing with the interval notation. We have 3/2 to 2, brackets around those. So any point that's in that interval will satisfy that inequality.